All right, let's get straight to it. For everyone in automotive engineering, the next 3 years are going to be, well, they're going to be everything. The winners and losers won't be decided by who has the better brand, but by who is the fastest and most efficient. In this briefing, we're going to break down the strategic shift you need to make to lead the pack, and it all starts with one number. A number that should honestly be keeping all of us up at night.
$45 billion. That right there is what automotive OEMs are bleeding every single year on warranty claims. Now, this isn't just some line item on a balance sheet. It is a massive financial anchor dragging the industry down. And it's a blaring signal that there's something deeply, deeply wrong with our current development and validation processes. A number this big doesn't call for an incremental tweak. It demands a revolution. And as if that wasn't enough pressure, the market is turning around and demanding what feels like the impossible. Cut the development cycle in half. Take the traditional 4 or 5 year slog and squeeze it down to 2. Speed is the name of the game now. So the big question is, how on earth do we get that fast without making that $45 billion problem explode? Well, the answer lies in what we're calling the efficiency revolution. And listen, this isn't just about trying to do the same old things a little bit faster. No, this is about completely re-architecting how we approach vehicle validation from the ground up. It's about a new paradigm, really, one that's driven by software, data, and a whole lot of automation. This slide really says it all, doesn't it? On the left, that's the world we're leaving behind. The rigid, slow, one step at a time V model. It's all about hardware. And on the right, that's where we're headed, the DevOps infinity loop. It's fluid, it's continuous, and it's defined by software. You build, you test, you release, you monitor, you learn, and you do it all over again, constantly iterating at the speed of code. So here's the absolute key takeaway. The new paradigm, the one that actually solves for both speed and quality, is a closed-loop development model, one that is software-defined at its core and just relentlessly automated. This is the principle that lets you have your cake and eat it too, moving faster while actually improving quality. Okay, so to make this tangible, we've broken this new paradigm down into 3 core pillars. These are MEES, mutually exclusive, completely exhaustive. They work together to form a complete strategy. First, virtualization, or what we call shifting left. Second, AI-powered automation. And third, robotics and unmanned operations. Let's dive into each one. So, Pillar 1, virtualization. This is all about taking the proving ground, the test track, all of it, and moving it into the digital world. And the key is doing it much, much earlier in the development cycle. It's about finding and squashing bugs in the software before a single piece of metal has even been stamped. And the core tech that makes this happen is called SHIL, or X in the loop. The best way to think about it is like a spectrum. You start on one end with model in the loop, that's pure software simulation. Then you step up to software in the loop, testing your actual production code on a virtual ECU. And finally, you start plugging in real hardware, like a steer-by-wire system, into a hardware-in-the-loop rig. It's this seamless flow that's the real game changer. And this quote, this is the holy grail. Virtual sign-off, imagine being able to confidently validate your entire vehicle system in a super high-fidelity simulator. You could sign off on it before the first, incredibly expensive, time-consuming physical prototype is even built. That's the goal. Okay, pillar number 2, AI. And let's be clear, this isn't about buzzwords or hype. This is about applying intelligent automation as a very practical tool to make every single part of our testing process faster, way smarter, and, this is the really exciting part, predictive. A perfect example of this is active design of experiments, or active DOE. You know the old way? We just brute force it, testing every single point on a massive grid. While active DOE throws that out the window. Instead, an AI algorithm intelligently hunts for the critical test points, the tricky, nonlinear, noisy parts of a system's behavior, and focuses all the testing effort right there. It's like switching from a shotgun to a laser-guided missile. And the results? They speak for themselves. Just look at this. For e-motor calibration, a notoriously huge bottleneck. The traditional method is a painful 8 weeks. With active DOE, we're down to 4 weeks. That is a 50% reduction. Cut in half. That's a massive win. And this isn't just us talking theory in a lab. This is a direct quote from the Renault Group. They've made this AI-driven method their official tool for tuning their electric motors. You can't get much more powerful validation than that. It's delivering real results right now for major OEMs.
Okay, on to our third and final pillar, robotics and unmanned operations. So, for the physical testing that we still absolutely need to do, we're now removing the single biggest source of variability and limitation, the human driver. Robotics are taking over, and they're bringing a level of consistency and speed that's just, well, it's inhuman. 2 centimeters. Just think about that. That is the path following accuracy of a modern driving robot. This isn't just a little better than a human driver. This is the level of precision and perfect repeatability that is physically impossible for a person to achieve, lap after lap, day after day, test after test. So what does that precision get you? It unlocks 24/7 lights-out durability testing. You can have fleets of 20 or more vehicles running around the clock, racking up mileage, all managed by a single operator sitting comfortably in a control room. This just massively accelerates one of the longest and most grueling phases of validation. Now, even when you're back in the lab, it's all about making smart choices. There's no single best tool for everything. Take a look at this. For heavy trucks, or if you're working on a tighter budget, a good 4 or 6-post rig is a great cost-effective choice. But if you're doing deep performance analysis on a high-precision passenger car, investing in something like an MTS 329 simulator is going to give you data fidelity that's on another level. The point is, you need a smart, strategic approach to your hardware investments. Okay, so we've laid out the big picture, the paradigm shift. Now for the most important part. This last section translates all that strategy into direct, actionable imperatives for you and your teams over the next 24 months. Think of these as your marching orders. These are the moves that will separate the leaders from the laggards. We've distilled it down to 4 key recommendations. Now, all 4 are critical, but for the sake of time, we're going to zoom in on 2 of the most urgent ones to get started on right away. Implementing a seamless model strategy and deploying smart gateways for your end-of-line testing. Let's start with number 1. We have to stop the insanity of rebuilding models from scratch for every single stage of testing. You know what I'm talking about. A model for SIL, then another for high-L, then another for the testbed. It's a huge waste of time. The move is to adopt a unified toolchain where a single model can be reused across all of those environments. The target here is clear, and it's totally achievable. A 40% reduction in model prep time. That's just pure, simple efficiency. Now for recommendation 3, which tackles a massive headache on the factory floor, end-of-line testing. You absolutely must deploy smart gateways that can bridge the communication gap between your components world, its in-vehicle network, like CAN-FD, and the factory's automation network, which is often EtherCAT or something similar. And this is crucial especially for EV components. These gateways must have greater than 1 kilovolt of high-voltage isolation. This isn't a feature, it is a non-negotiable safety imperative. So I'll just leave you with this one final thought. As we speak right now, your most aggressive competitors are on track to automate 60% of their entire testing workload by putting these very strategies into practice. So really, the question is no longer, can you do this? The question is, can you honestly afford not to?